Hello everybody, it's Joey again. You're watching Vegas D-Tech. This is Tech Talk number 35. And today I want to talk to you a little bit about jewelry, silver more or less, and how it rings up on a VDI scale. Why some pieces of jewelry that you might be detecting rings up low when it should ring up high. If that's interesting enough to you and you want to hear more, stay tuned. We'll be right back. Alright guys, we're back. So today we're going to be having what I call here the silver report, the clarity, okay, discussion. Alright guys, so I made a video a little while back where I had stated that the jewelry that I had found at a certain range on a VDI scale. And I had stated that the gold rings that I had picked up, they were hitting on a particular number. And the number on the detector that I was using, which was a 13 kilohertz Quest Q40, that number where I got the gold rings from, okay, that number was 56 to 58. That's where these came in, okay, and that's on a VDI scale of 0 to 100. All right, and then I also stated that of all the silver jewelry that I've ever found, at least 80% of my jewelry that I've found that was silver rang up as a dime, quarter, or higher. Okay, the silver rings here, they rang up that way. Now, I thought that this was obvious. You know what I mean? That ferrous items will ring at the very bottom of the scale, non-ferrous items ring in the middle of the scale, and that silver rings high in the scale, right? This is not rocket science. I didn't make this up. I didn't just create this, okay? This shouldn't even need to be discussed. For those of you that have been detecting for longer than a couple of years, you guys already know. Let me show you exactly what I'm talking about. All right, so in this video, this little clip that I've got here, Steve Hirschbaugh, he's an administrator for Detect Prospector magazine. He talks about gold and why gold is a good but not great conductor. We know that the number one conductor of metals out there is going to be silver by far. People always say, well, if silver is such a good conductor, then why do they use gold in electronics? Well, it's not so much for its conductive abilities. The reason why gold is being used in electronics is for its anti-corrosiveness. It doesn't corrode as fast as silver would. Okay, it's very anti-corrosive, and that's the reason why they use gold. But if you take a look at the scale right here, it clearly shows you right there at the very top of the scale, silver is number one when it comes to conductivity, right? Followed by copper, and then coming in with gold being third and aluminum underneath that. All right, now that little graph right there is basically showing you that, you know, one of two things that we need when we metal detect is we talk about the metal or the target's ability for its conductivity. Okay, conductivity. And it shows you right there, we all know that the conductivity of silver is the absolute top. There's nothing better than that, okay? Now, the fact that people would want to leave comments and say stuff like, oh man, you know, I have silver that rings in under a quarter all the time. This may be true, but not all the time. It'll be some of the time. And there's a reason for that. You see, guys, there has to be more than making a statement and not clarifying why that is. It's easy to just go, oh, I'm going to make a video and I'm going to get a bunch of jewelry and we're going to make a video showing me scan all my jewelry, and this is the reason, this is what you're going to see when I scan my jewelry. I'm going to show you that some of my silver rings high and some of my silver rings low. Okay, so hey man, I'm thankful that you guys made that video. That's great, but why? Do you understand why those silver items that you rang up rang low? Well, I have to make this report right here to explain why your silver items would ring low. Okay, now I didn't make this thing up, man. From the very beginning of time when I first started getting into metal detecting, the metal detectors would come with a VDI graph on it Okay, and it's still the same thing even after all these years. Let's take a look. This first detector right here is the best-selling detector ever, as far as consumer purchasing has ever happened. The Garrett Ace 250 is the #1 selling detector ever sold around the world. Okay, bar none. And if you take a look at the metric that is up on top there, it shows iron at the very bottom. It says gold right in the middle. And then at the very far right, you're going to see the coins, dimes, quarters, half dollars, and dollars. And what are those letters right above those coins? It says what? Silver, right? This is what Garrett proposed when they first made this out. They're saying that their VDI matrix, generally coins and jewelry will ring this way. Let's keep moving on. How about this detector? Here is the Garrett Ace Apex. This is probably the newest of the line of Garrett right here. And this is what? Look at the scale that's up on top. What does it say there? Iron at the bottom. They took gold out of it because they know that gold can ring anywhere from where ferrous items starts to break over into non-ferrous. We know that gold rings can start to land right in there all the way up across the board, okay? But interestingly enough, look at the far right. What does it show? It shows coin. And then what is the word right up above there? Silver. Okay, that's another one showing that silver rings high as a coin. Let's go to the next one. What is this one right here? Oh, this is the Garrett AT Pro. Take a look at the gauge that's up on top of there, right? What does it show? Iron at the bottom, gold rings right in the middle, right around 50 to 60, exactly where I said I found my gold. And at the very top there, where does it show quarter and where does it show dime, right? And what does it say right above that? Silver, right? I didn't make this up, dude. This has been like this for years, dude. Okay, next one. Here's a whites, man. Here's an old whites machine. The old needle type here. Again, they've even followed the same protocol. Iron being at the bottom, you could start to see where the needle wants to go to gold in the middle. And then right here, it shows that the gold, and then here comes all the clad to the far right. And if you take a look at the very top there, what does it say? Silver. At the very end of the spectrum, right? Let's go to the next one here. Here's Fisher. Fisher's detector shows the same thing. Iron in the bottom, gold in the middle with silver at the highest range. Next one. The whites. What is this? The Treasure Master and the Treasure Pro? Again, they're doing the same thing with their VDI matrix. Iron in the bottom, the gold in the middle somewhere, and then at the very top, where does it say that the quarter is at? Dime, quarter, and what's above dime, quarter? It says silver. Alright guys, so what I'm trying to point out here is that when I stated that 80% of all of the gold, all of the silver items that I've ever detected rang up as a quarter, I don't need to get people chiming in and trying to disclaim or discredit that. It's true. It's not arguable. It's not objectable. You know what I mean? This is a fact. Now, there are times when pieces of silver can ring in lower than lower than a quarter or a dime. Now, why is that? Why is that? A few things happen here when a detector tries to detect jewelry, okay? Number one, it's the alloy composition, okay? Why is your piece of silver that should ring high, why is it ringing low? It's its alloy composition. A lot of times you'll see 925. We don't know if that 925 is really 925. We don't know if it's like just because it comes out of the ground and it's real shiny doesn't necessarily mean that it's silver, okay? Many times those silver rings, they're alloyed with copper, they're alloyed with some other type of a metal to make it strong. Gold is that way. You can't just have 24K gold. I know that in Thailand, my mom has gold chains, and her gold chains are so coppery colored. The gold is almost like an orange color, and those are 24 karat. Those chains have to be very, very thick in order for them to be strong, because if they're thin, they'll break. And that's the reason why stuff like 14K and 10K is like what a lot of people wear, is because they compound it with another alloy to make it strong. All right. So number one, this is a silver jewelry box that I found in the ground. Okay, this is a little 925 silver jewelry box. This is silver. It did not ring like a quarter. It rang down in like the 60s. It rang like a penny. So we're going to go with number 2. If it's not the compound, it's going to come down to the shape of your piece of silver. Okay, this butterfly pendant that I have right here, I found this in a volleyball court. This is silver, but it rang not like a quarter. It rang like a penny. Okay, so this jewelry box and that butterfly are both silver, but they did not ring up in that range. Why? It's because of the shape. Okay, so you've got alloy composition and shape. Now, how does shape matter? Why does it matter? Well, number 2 on this thing here, the shape also. How does an object hold a magnetic field? Okay, that's right. We put a signal into the ground. It hits a target. That target generates a magnetic field. It holds a magnetic field, and then a signal comes back from that. And with that information, your control box uses that information to give you VDI and tone back. All right. Now, what was very interesting, man, is I did a test. I took this ring that I found, which was a silver class ring. Okay, silver class ring. That silver class ring right there rang as a it rang in as a 95. All right. I took this silver ring and then I took a Dremel and I cut a slit down in the bottom here. I don't know if you could see that. Right down in the bottom right there, I cut a slit in it. Okay, this thing went from a 95 on the VDI meter down to a 78. Okay, down to like a penny tone. Why? Because I took this thing, which is like the perfect round shape, so it held a magnetic field perfect and came in the number it should have came in. And by cutting this little slit right in here, it came down to a 78 because I broke the magnetic field on it. Okay, these items here, when I said that 78% of the stuff that I found came up in that range. Why? Because first of all, coins, they are refined in the perfect shape, the perfect round shape, and that will generate an awesome magnetic field to bring the number up high. And if you take a look at the common denominator in these rings, is they are the perfect shape, man. The roundness of them, they're perfectly round, right? When you get an item like this ring right here, here's a silver ring. This silver ring did not ring high as a 25 because it has this, this is a butterfly ring. And it's just the shape of this ring right here that put the VDI number off. And it made it all off and crazy and brought it down to the penny range, okay? So, and another thing that's really funny is, see this bracelet right here? You would think that this bracelet, being that it has a lot of metal on it, that this thing would ring high, right? Wrong. This thing on the Equinox, I believe this thing came in a number 6, man. Right? What is it? I mean, I'm not too sure. I bounce around detectors, so the numbers could be wrong. But I believe quarters normally come in like 30, 31, something like that. And this came in a 6. Look at all that metal on there. This came in a number 6. Now, here's a silver bracelet, right? This silver bracelet right here, you know what this rang in as? This silver bracelet rang in as like a 1 or a 2. And the reason for that, man, is that the detector is detecting each of these little links by itself. This does not generate a very good magnetic field because of the links keep breaking it. It cannot emit it's not conductive all the way through because the links break it up. Okay? Same thing with this chain right here. The links, each individual links breaks up the magnetic field, and you don't get the opportunity to actually get this solid thing, you know what I mean, that will actually generate a strong magnetic field and give you that high tone. All right, guys. So look, I'm not trying to win a Nobel Prize with all of this information. And you know, I don't know everything. I don't profess to know everything. But you know what? There comes a time when you do know what you're talking about, that you need to explain things. And I know for a fact that what I'm talking about with silver ringing high, this is generally true. This is generally true for years, man. I mean, I'm not trying to rewrite history. Every day I see people trying to go and rewrite history. They don't like it, man. They want to just tear that page out of the book and rewrite it. You know, oh, Christopher Columbus didn't discover America. Rip, throw it away. They don't like General Lee and, you know, the whole North and South battle that happened. It is history, guys. You just can't rip it up and throw it away. You know, oh, Pluto used to be a planet for the whole time that I was in school. Oh, all of a sudden now Pluto's not a planet. Just throw it away. Bro, you can't just throw things away. You know, this situation where I show again, ferrous, non-ferrous, okay? Ferrous items ring low, non-ferrous items should ring somewhere in the middle of the spectrum, so gold can ring anywhere from where ferrous and non-ferrous starts to overlap. Gold can ring anywhere from there all the way up to around the silver range, just because of its composition, its alloy composition, all right, and shape. And with silver, silver is the best conductor of all the metals. It should normally ring very high for the majority of the time. Watch out without saying the word always, because someone's going to go out there and try to break you down because you said the word always. So I'm not going to say always. I'm going to say generally, okay? Generally, your silver should ring up high in that range, guys. So, guys, I just wanted to bring some clarity to this matter here of where, you know, jewelry rings up. And for me, I think that I've found enough. You know, I've found enough with different detectors to have a general idea of what things sound like in the ground. Am I fooled from time to time? Always, man. Always I get fooled. But I want to know why, you know? And I try my best to not just come on here and spout off and just tell you some stuff or do some type of an air test without trying to qualify what the point of that air test was and why it happened. You know, when somebody goes out and they detect and they find jewelry, it's nice that they found some jewelry. It would also be nice to find out from them how they think that they found it. Like if they're consistently on a pattern of finding jewelry, I'd like to know more about how they find it. Is it just a matter of they go out every single day? If they go out every single day, like Paystreak, he goes out every single day. I don't care if it's snow. This guy's taking his coil and pushing it through the snow. That is some seriousness right there. Or somebody like Gigmaster. You know, I give Gigmaster a lot of props too, because when Gigmaster goes to the beach and he starts finding lots of rings, he likes to explain why it was. I never really understood beaches and like the cut, but he would explain that he would go out there and he would detect really hard and he would not get anything, and then a storm would come in and his friend would call him up and tell him to come back out there, and there's a big cut where the storm surge, the waves would come in and it would actually make a cut on the beach where it would take all that sand and just pull it out and then push it back in kind of like a sluicing action. But you could clearly see the bank where all that sand would break down like 4 feet and just go out and be sluiced. And they would go out there at that time and detect, and they would find a whole bunch of stuff, rings included, and that's the science behind how it worked for them. So I'm just trying to give you guys a little bit of a, you know, heads up as to why jewelry does what it does. Remember, guys, man, it's going to be a lot of things. Alloy composition, number one. The shape or how that item holds a magnetic field will be number two. Okay, number three, the angle. Okay, that's just an air test right there. When we start talking about in the ground, that opens up a whole nother can of worms in itself. The angle that it's in the ground. When these guys are doing tests like open air test, they're giving you that perfect, they're holding it right here, just going perfectly back and forth, and you know that this item is not sitting in the ground like that. And they're using the perfect medium, which is air. There's nothing between a detector's coil and that object other than air. So it's like it's got absolutely no resistance to fight through. So once again, that's going to be another reason why the number is always perfect or whatever, or even how it reads. So number four or five. Number five, mineralization. How much mineralization is in your ground? That's also going to affect how your VDI acts. Also, ground moisture. Did it rain recently? Does the park that you go to or the field that you're in, do they have sprinklers out there? Is the ground and soil wet? You know, that has another key to play. And then last but not least, the frequency of a detector. You know, some detectors operate in 20 kilohertz, so whatever my X-terra operates at 1875, it's going to hit with a different VDI number than, say, me using, the Equinox at, 15 kilohertz or in multi. Or if I were to use the Quest, and that's in, I'm using 13 kilohertz. So many different variables there, guys. But the number one thing that I want to tell you and show you was those actual faceplates of these machines on here. They have those VDI, templates up on the top there, and it's been like this, man, for what, 30, 40 years maybe? Nothing has changed. I didn't create that stuff, man. It is what it is. If you don't like it, you don't like it, but that is the business, okay? The engineers of those companies felt fit with all of their research to put those meters on there to prove a point, and I followed it, and that's how I learned, and it's worked out this far for me. So anyways, guys, that's all I have for you, man. I hope you guys got something out of this here. If you liked it, please give me a thumbs up, subscribe if you haven't already, and we'll get back with another one of these hunts here real soon, and I'll get back with you on my next video, on the next upload. Alright guys, you guys be well. It's Joey Vegas Detect. You guys take it easy.